Am I audible?
Yes, ma'am, you are.
Am I audible?
Yes, sir, you are audible, sir.
Okay.
Shoma ma'am, can we start? ফোন করবেন না। হ্যাঁ ঠিক আছে, শুরু করবো। আচ্ছা ঠিক আছে, তাহলে বলে দিন।
Just wait for 5 minutes. Actually, in some places there are heavy rain. That's why participants may be little bit late. Just wait for. Moumita, start introducing sir, and after that we will start the session.
Okay. Am I clearly audible?
Yes, you are audible.
Good afternoon, everyone. On behalf of the organizing committee, I, Momita Goswami, extend a warm welcome to you all on the third day, fifth session of the AICTE sponsored 6 days online ATAL faculty development program on quantum edge intelligence organized by Department of Computer Science and Engineering of MCKVIE Institute of Engineering. Today, we are honored to have with us Dr. Indrajit Banerjee, who will share his rich knowledge and expertise on introduction to edge computing. And it's my pleasure to introduce our eminent speaker. Dr. Indrajit Banerjee is currently a professor in the Department of Information Technology at IIEST Shibpur. He completed his from the Bengal Engineering and Science University, Shibpur in 2014, with research focusing on cellular automata-based sensor network management. With over 2 decades of academic and research experience, Dr. Banerjee has significantly contributed to the field of wireless sensor networks, Internet of Things, cloud computing, cybersecurity, and consumer electronics. He is a two-time recipient of the prestigious Chester Sol Award from the IEEE Consumer Technology Society and has received multiple Best Paper Awards at renowned international conferences. His contributions have been recognized nationally as well, including the Computer Engineering Division Prize by the Institution of Engineers in 2023. Dr. Banerjee has supervised numerous PhD scholars, many of whom are now faculty members at leading institutions such as IIT BHU, Jadavpur University, Alia University, IEM Kolkata. He has led and coordinated over 15 major sponsored research projects funded by agencies such as DST, AICTE, UGC, MOIL Limited, MIT, and West Bengal DHESTB, with cumulative funding exceeding several crores of rupees. His innovative work has resulted in multiple granted Indian patents, including technologies for smart healthcare in post-disaster scenarios, urban VANET routing, IoT-based environmental monitoring, and real-time water and air quality monitoring systems. Additionally, he holds software copyrights for tools in the domain of genetic algorithm simulation and machine learning performance evaluation. Dr. Banerjee is a regular reviewer of top-tier international journals, including IEEE Transaction on Vehicular Technology, IEEE Internet of Things Journal, Elsevier Ad Hoc Networks, and Computer Communications. He is also actively involved in national academic administration, having served in leadership roles such as Associate Dean, Co-Chairman of the Institute ERP Implementation Committee, and faculty in charge of Network Infrastructure and Service Cell at IIEST Shibpur. A prolific author and speaker, he has published extensively in reputed journals and conference, delivered invited talks across India and abroad, and actively organized numerous FDP, symposium, workshop. His academic service and research excellence continue to advance the frontier of intelligence systems and digital infrastructure in India. Without further delay, I now request Sir to carry out the session. Over to you, Sir.
Thank you very much for that entire detailed introduction of mine. However, it is not required because there are a number of students with me are associated and they all know. And the circle is very small in this academics. In the Eastern India, we are part of the research group where we are doing a various research in various fields. As you have already mentioned, my main area of interest is that IoT, cloud computing, and cybersecurity, as well as various other areas where we are also exploring now to get a breakthrough. So I'm here to share my idea and knowledge on the area of edge computing. So let me first share my screen so that my screen is visible to all of you?
Yes, sir, it is visible.
So today we would like to discuss with you about though I am very new in this particular field and area in cloud computing, but still we are exploring this area last 3-4 years, and where few of my research scholars are working with me in PhD and MTech level. Actually, today I would like to share with you the idea that have we achieved from that particular domain of research in edge computing. So let me start this particular thing where, and first of all, I am thanks to the committee members, and it is my pleasure to share my knowledge and thoughts with all of you over here in this platform. So this is the outline of my today's talk about the edge landscape. So without further delay, let me go into the topic. So here, the first slides we are going to, I don't know, this slides is not overlapping because it was designed from Google Classroom, Google, that's why it is Can I open other one? Okay, ठीक है, it's okay. So the first slide, it is I'm discussing with you about the edge computing basics. So edge computing, if you see that it has started some. Yeah. So if you see, it was projected that by 2025, there are 180 gigabytes of memory data are supposed to be get stored. I don't know how to remove this particular thing. Of data can be generated. So this volume of data has to be stored somewhere in the cloud. So that is the major issue that we have to consider. Another issue is that mitigating the cloud latency, because cloud means what? Cloud means we understood something which is not visible to me. A server, that may be a rack, that may be a that may be a blade server, that may be a cluster server, whatever it is of kind, it is not there in my premises. It is there somewhere in other premises, and I am supposed to use it via internet. So when I'm going to use something via internet, it is definitely depending on the distance of the server. It definitely need a time to access that particular facility, that particular resources. So when we are doing something on real time, this creates a huge problem. So when we go for mission critical issues like healthcare services or autonomous vehicle services, in those areas where the real-time data processing and the decision making is very important in nowadays. Say, for example, in case of autonomous vehicle drive, we have to take a decision very immediately on the basis of road condition. In case of healthcare analysis, on the basis of patient's informations, you have to take a immediate decision, otherwise something goes catastrophic. So there the delay is very important. So there the edge computing is very important. We are coming into that particular area. Why edge computing is here gives us a importance in case of mission critical cases. The last point is that enhanced privacy and sovereignty. So obviously, when we are accessing something over the cloud, we know that in modern world of digital data access, the problem of data security is a major issue, right? When we are going to access anything on cloud, we have to be very much careful about our data authentication, about our security of our data and all. So this is one of the major area or concern in today's world of cloud computing. So this shifts the drive. The research focuses on optimization, intelligence, and robust security at the edge level. So what is edge? What is cloud? What is this? So let's discuss first about this. So let's discuss about what is edge, what is cloud, what is fog. So this three terminology we normally use in case of cloud computing. First of all, let us discuss about cloud. Cloud is what? That is what is already I have discussed with you. This is not something in my premises. This is something which was stored in a remote place, which is not visible to me. And the resources, since it is not visible to me, and that is supposed to be get access through internet connection, so there must be a latency is very high. So latency means the response time. When I'm uploading some query to get some data for me, it will take a longer time. Longer time means few milliseconds. That milliseconds even matters sometime with us, because for mission critical system, it is very important. And in today's modern world also, we are not that patience we have. We are very much hurry in our all work. So we are not happy if the response will take a long time. So what we'll done for that, we have introduced the intermediate layer. Intermediate layer means something which is in the remote cloud and with your device in your hand. The device, before I go into the intermediate layer, let's come to the edge. Edge means the device, whatever you are using for accessing the cloud is the edge devices. So normally edge is nothing but your laptop. You can consider your mobile phone is a edge device. And in modern world of IoT, all the IoT devices are considered to be as edge devices, which are supposed to be get connected to a central server in the cloud via our internet connections. And the edge device are a device, kind of device, which will do sense the environment and collect the information and do some processing. That's what we today's modern demand of edge computing. You have to do some kinds of local processing in your data so that your access of the data from the central cloud will be get minimized. So that local processing will give you some additional advantage of reducing the access time of the central cloud, reducing the data transmission. So the cost involved behind it also decreases, as well as definitely as you are decreasing the data transmission, you are definitely also enhancing the other quality like carbon footprint also you are going to reduce. So to get access between the edge and the cloud, we introduce an intermediate layer, that is a fog layer. This fog layer is basically an intermediate layer between the edge and cloud, which is basically a server, not maybe in my premises, maybe outside premises, but near to me compared to that of central cloud. So what will do by the intermediate device? This intermediate device will perform some local computation, help me to do some local computation with my handheld low-end devices. Say, for example, in my campus, I would like to install some camera. That camera are supposed to use to monitor the vehicle movement in my device, in my campus. So that camera is just nothing but the edge devices, which will capture the image and do some computation on that device. But that camera don't have that huge amount of hardware support to do the other processing. Say, for example, I would like to detect the number plate. Want to detect the face of a person. I would like to recognize the students and the faculty separately. So this kinds of high-end processing is not possible in case of edge device, in case of camera. And to do, I can obviously do that kinds of processing in a cloud, but I want to reduce the congestion. I want to reduce the response time. So I have introduced one server in my local premises to do the local processing of the cloud of the camera data, which was captured by the different CCTV in my premises. So this intermediate server that was installed inside my campus is considered to be as a fog devices. So they are in between the central cloud and the edge devices. So they are considered to be as an intermediate devices. So these layers form the seamless continuous optimization and data processing from the device to distant server based on the application requirement. So depending on the application requirement, as I already given you an example, you may need a intermediate fog device, or you may don't need the fog. You can only have a cloud and the edge service. Now move on to our today's topic of discussion, that what is the edge computing and its corresponding research area, where we are basically today's modern world of research are moving. So there are various areas. Vibrant research landscape are rapidly evolving and driving the more efficient, intelligent, secure edge deployment across the various domains. As I already discussed with you, in case of modern world, with the introduction of IoT devices, the edge computing has given us an enormous features, enormous area where we can do a research. So one of the major research area is the resource management. Why it is required? Because the edge devices, that what is example are your camera, your maybe your simple bulb. That bulb is going to control by your mobile phone. That bulb is an edge device which will having some sensors to know the ambient light, and accordingly it will adjust its luminance. So the sensor attached with my bulb, which is collecting the luminance of my room, and accordingly it will adjust its brightness. That processing I need to do inside the bulb only to reduce the complexity of my processing in the cloud, right? So now we have to consider what is there available inside that bulb, inside that simple bulb, electric bulb, maybe a LED bulb, that have a very little processor, that have a very minimal, maybe 1 KB or 2 KB memory size. So with that, we have to do a lot of processing. So that is what is the resource management is very important in that area of for edge computation. Now, today is the age of AI. Everyone is doing research with AI. Now, since it is AI means one of the domain of the AI is machine learning. As already we have discussed that resource is very constrained. So we cannot run a high level AI ML algorithm into our edge devices. So we have to rely on tiny ML. Tiny ML is a kind of ML algorithm platform which give us a low end ML solutions, right? That we can perform with our resource constrained devices. So there also there are people are doing research in this tiny ML with the tiny ML and all. Obviously, the third parameter, an important parameter, is security and privacy. Security and privacy is very important in case of edge computing because the devices, whatever you are installing in your premises or in the other premises, which can easily get breached by someone else. Or during the communication with the edge device, with the central cloud, during the communication, anyone can eavesdrop in your communication and can do some passive as well as active attack. So you have to apply a proper security measure into your communication, into your devices, so that you can resolve those kinds of attacks. So intrusion detection is also a major area of research in this particular area. Here I have mentioned the intrusion detection because one of the group of my students are doing a good research in that particular area. Obviously, other than intrusion detection, there are other kinds of security research are also going on in case of edge computing. I'll discuss one of that of today also. Network innovation. So obviously, we know that we are already in the 5G era and we are moving towards the 6G era. So all the devices has to get integrated with a modern security mechanism like 6G, software defined network, network function virtualization. These are the new area of research where people are doing research for intermediate communication establishment between the edge and cloud devices. So this is a huge area of research are going on that particular area. Huge potentials are behind it. And none other than energy efficiency is obviously, it is always obvious area of research everywhere. Whenever I started my journey with a WSN, wireless sensor network, I did my research with energy efficiency at that platform. Now the WSN get evolved into the IoT. People are also doing the research in IoT with edge energy efficiency. And now with the edge computing in the cloud environment, also we are doing the research with the energy efficiency. Why it is so important? Because energy is the major area of interest in our model world. You know that in modern geopolitics also, the energy is a major concern. From where India is going to purchase its energy, that is the major concern nowadays with the other global leaders, right? So energy is very important. Even if in tiny level, if you can save a little bit of energy in a big environment, definitely you can get some big results. So to do the sustainable eco-friendly operations and minimal power consumption is a major area of research in today's world of edge computing research. So with that, let me move to the next slide where we are going to discuss about edge AI empowering the intelligence of the sources. Edge artificial intelligence That means artificial intelligence, which are going to be introduced in the edge devices, that are basically major three area I would like to mention over here. The first is the federated learning. Federated learning means it is a privacy preserving distributed learning mechanism. So normally federated learning is a mechanism which AI, obviously AI based model, which gives us an idea that how you can preserve your privacy, but in a distributed environment. So instead of doing the intercommunication in a central locations, you can do some computation in the local distributed mode in the edge devices, and collectively you provide a privacy preserving mechanism to all of the devices. That is the major area of research in today's world of edge computation. Already we have discussed about the tiny ML. Since machine learning is one of the major area of research in nowadays, and the microcontroller that we are using in case of edge devices or in IoT devices, they are very low power, low resource. So low resource means its computation and the memory both are very low. So we have to rely on the tiny ML. So you do the just search on TinyML, you will get a hell lot of documents behind it, and you can do a lot of research on this particular area. On-device inference, this is another area where I would like to give an importance that in the modern world of edge computation, Google has introduced the edge TPU. The ASIC is another area of research, and obviously GPU is this is the most important area of research in nowadays, or hardware that we are using for our AI ML applications. So these are the important thing what I would like to point out, which we may consider. GPU is obviously for any hardware. GPU is important for parallel processing and parallel computation. So as we are doing any kind of research in ML, any kind of research in deep neural network, as we need to do our parallel processing, we need a GPU for its computation. Similarly, ASIC is an area which is an application specific chip we are going to design for a specific purpose. So the VLSI peoples can also do a research in the edge computing by designing a specific chip for a specific devices, right? Specific edge devices. So which is also very important. And edge TPU is a Google invention, which is also for edge devices. So these are the also an area where we are doing a major research. Now, edge security and privacy innovation. So I'm moving towards, instead of discussing about the edge, let me discuss about the security and privacy innovations, because it is the major area in nowadays for edge computation research. Every students out of 10, 9 students are coming to me. They would like to do some research on security. Why security is so important in today's world? Because every day we are all facing a different kind of security threats in our daily life. Every day we are getting fraud calls. We are getting our email get hacked. Our bank are providing us a false alarm, and number of times we are getting a false kind of phone calls. We are getting a number of anonymous links. If you click it wrongly, if you do something wrong, you will be in trouble. But with that problem also, we are heavily dependent in nowadays in edge computation. Why? Because we are very much important, very much familiar with the modern somebody is try to use the same screen. Please don't use it.
Participant, do not alternate on the screen.
Okay. Somebody is also sharing the same screen, and that's why they have make it them. So, okay, not an issue. So the first topic that I would like to discuss about the secure data offloading. So confidential and authenticated transfer between the edge node and the cloud infrastructure, preventing unauthorized access, is a basic important factor in today's modern world of edge-based communications. So edge-based communication means a very simple example of edge is your own mobile phone. So when you are accessing any of the cloud-based services, say for example, whenever you are accessing your bank from your mobile phone, you are doing a cloud computing, cloud edge computing. Your mobile phone is acting as an edge device, edge computation device, where your mobile phone applications, maybe you are using for SBI or any other bank application you are using, that is a edge computation is done, going to be happened in your mobile phone, and the server, bank server, is the cloud server. Now, when you are doing any kind of transactions, your authentication, your confidential transactions, data communication have to be keep it secured to give you a proper support. So for that, blockchain and decentralized ledger technology is also an important area of research in nowadays, which give us a tamper-proof data integrity and trust at the edge, and by enhancing the transparency in communications, right? So blockchain-based research is nowadays very important. People are doing, a lot of students are doing research on this particular area and across the globe. And the third point that I'd like to discuss with you is quantum safe cryptography. Why it is very important now? It is getting very lucrative area of research, because already Google has introduced its quantum chip. Other companies like Microsoft and others, like also the Alibaba and all, they are all trying to develop the quantum chips. What is the difference between the modern chip, whatever we are using, and the quantum chip? The major difference, in one word we can say, the computation facility in quantum chips are quite large than that of the chip which whatever we are using. Say for example, if you have a NVIDIA GPU, which will do a processing within 5 seconds of time or 1 second of time, that same computation can be done in a quantum-based chip within a nanosecond of time. So the difference is the problem that we are facing, the cryptographic algorithm, whatever we have, if you consider, take name of any cryptographic algorithm like RSA in the public key private key algorithm, or in the DSA in the secured communication algorithm, these are the standard algorithm we are using for our modern communications, right? When we are doing this transactions on the bank, we are heavily dependent on the RSA algorithm, on the DSA algorithm. So what we can do, we can increase the DSA to increase that key size, but the 128-bit is not fair enough with the quantum safe, quantum-based machines. So that can easily be breaked with a brute force attack if the chip is quantum. So we have to enhance and study well about the algorithm which are quantum safe. So quantum safe means quantum-based processor safe, which can do the even protect our communication, even if the chip in future will be a quantum chip, right? So with that, people are doing research in my IST also. Our students in my group also, we have started a very preliminary research on quantum safe cryptography also, so that we in future we can are at par with the others. Privacy preserving technology, where one of the important name is homomorphic cryptography encryption. Homomorphic encryption, why I am giving a name, because this is also a very catchy area where people are doing research, because homomorphic cryptography encryption is giving you a facility without decrypting any data. You can go on to check the data. That means you are processing a data, you have received the data in the intermediate layer, and without opening that data, without decrypting that data, you can do some processing and authenticating is that data belongs to someone else or not without opening that data. That is what a homomorphic encryption algorithm provides us. There's a different privacy for sensitive data analysis without compromising the privacy. That means you are not decrypting the data, but even though you can able to check whether the data is authenticated one, whether data is proper or not, that is what, without knowing what is there inside. So that area is also very challenging and very interesting. People are doing research in this area as well. Achha, whoever has done this, I don't know how to delete these things. Can I delete it?
Sir, can you please stop sharing your screen and share once again?
Okay.
Uh,
So let me now this time instead of using that, let me open the service where I am. Oh, I'm in the Zoom, right? I'm in the Zoom. Share. Now, can I share this? Let me check. Share. Now the screen is properly visible because
Right,
now I
sir.
have opened the PDF version of it. Okay.
Right, sir.
Now, how to move it?
Sir, you can go to full screen mode. In view menu, there will be a full screen mode.
Okay, so this is not a full screen. Okay, Control L is the full screen. No, it is not full screen.
Sir, there is a view menu at top.
Video. No, view. Layout. Annotation. Annotation is here.
File edit view.
Sir, in the
It is not there.
PDF, sir.
In the in the PDF you are talking
Right,
about.
sir.
In the PDF also only view and then make it full screen. This is a full screen. Control ऐसे
Yes, sir, Control L.
हाँ Control ले हो जाए किंतु अच्छे ना somehow no it's fine.
Yeah, sir, it is fine.
Now no, how to move it?
So page up and page down, is it working?
It is working. So next page that I'd like to discuss is about the age with 5G and 4G, 6G. So this is the another area of research people are doing, though this is not my area of research, but still I would like to say this particular area because in my department also people are, in my department as well as in the electronics department, Shoma ma'am is already here with us. Suma is also has done a good research in this particular. Probably she has not. I have no idea, but she belongs to that area, so she will enlighten you better than me. But still, I am taking that opportunity as a speaker to tell you that those who are in the electronics background, even if computer science people are also doing a research in the 5G network, and for now it is 6G, where one of the important area is the ultra low latency, which is very important. Then mobile edge computation is another area of interest where the European standard body has already standardized few of the protocol and algorithm, as their IEEE have not yet done it very well, but European Union is always ahead of in case of cellular communications. European Union, in my opinion, is always one step ahead of US group. So they have already standardized this particular area for edge communication also. And edge orchestration in 5G is another thing that basically what we are doing. There's a fancy word we have used over here. Orchestration means you are doing something with a 6G in a good fashion. So in 6G, the major area is the resource management, and that is in dynamic wind fashion. So dynamic resource management is major challenge here. The resource means not the memory, not the chip, but here the resource means the major resource is the band, the signal band, what you are using. So when you are communicating the data between the edge and the server, the communication can be enhanced its quality, can be enhanced its latency, reduce that latency obviously, and can securely send its data over the wireless media using the 6G. So this is a major challenge, research challenge people are doing in this particular area, and people are happy with that. Though my things are not that, I'm not that expert in that area though, but still I can say this. Again, I stuck. I don't know how. Oh, it is backing notes forward. Okay. Now here, navigating from the open challenges, what is there? One of the major open challenges that we have is a multi-objective optimization. That basically for balancing the latency, the transmission latency, cost. Here the cost means your cost of communication, cost of computation, energy, definitely utilization of energy, and quality of service. These are the basic area where we will do the optimize the in a multiple way with the multiple parameters. Standardization and benchmarking. Already in 6G, I have mentioned that IEEE and IET already standardizing, and also these are the area where also we need a lot of standardization operations. Trust and interoperability. Trust and interoperability is a major area. Why? Because in today's world, when we are going to purchase any product from the market, we are purchasing, there is a no single supplier is available. A single company is available which will develop the edge, fog, and the cloud devices. So we have to go and purchase the different edge devices from the different company. Say, for example, when you are going to install a camera in your system, the camera may be of different company, the intermediate VLR may be of different company. So you have to make an integration between them so that there will be a seamless operation will be carried out. So the ecosystem of the devices is very important. Ecosystem of the devices means the chip is made by someone else, the memory is made by someone else, the body is made by someone else. But when we are integrating them together, entirely the device should work as a seamless performance. So when we are considering the edge, the fog, and the cloud computing, there also we need this trust and interoperability features. Sustainable infrastructure. So eco-friendly and energy efficient edge deployment in a long-term visibility and reduce the environmental impact. This is very important in today's modern world of discussion, where we need a lot of things in our. So sustainable infrastructure is very important. So we have to develop, we have to do our research in such a way so that it should be much more energy efficient, and it will allow us to continue our services to the future world as well. So the next is the future direction where the edge computing research is going on. To discuss on that particular area, we would like to discuss about the quantum edge intelligence. So quantum computing is quantum machine learning. Quantum computing is the modern area of research where people are doing a lot of research. And so we have to give an importance on that quantum edge intelligence research also. So this area is enhancing the security and the processing power of the area. Cognitive edge network means here also this network is a kind of network which is self-learning and self-optimization. So this is also a research in the domain of domain of networking as well as a decision making. So whenever you are doing intelligent decision making, that you have to do using a cognitive mechanism. Blockchain and edge AI already I have discussed, and bridge and edge computing that already we have discussed, because here people are using this particular features parallelly. Please don't use it, right? It will create a problem.
Sir, is this the annotation is from your side or participants are doing
Somebody
it?
else are also using that annotation.
Sorry,
Somebody
sir?
else also using this. So let me again, should I go? I don't know how to delete these things. So let me go to the annotation and delete all these things. So clear all drawings. Yes, it is. It's fine. Now let's move on to my area of research, where what we are doing in IISc Shipur. Now in IISc Shipur with my team, here I would like to mention this is the Rajyasree Kunwar. She is from Guwahati. She is a faculty over there and came to IISc Shipur for his PhD work. G Techno3 is my MTech students and myself. So see the combination we have done. We have taken everyone from other groups. Even sometime in our paper, this is one of our paper that already we have published in a conference, and the journal version is going on. A few rounds of your review is going on, probably going to be published soon in a journal. Before that, I cannot disclose everything. So, but let's share the some of the area of what we are doing. So this is a cancelable biometric approach we are proposing. What is cancelable biometric approach? This is for secured privacy edge computing mechanism. So let's go on to and let's see what is this. In this particular area, we are basically securing the biometric authentication at the edge level. So what is biometric authentication? Biometric authentication means a person is going to access his devices through his biometric information. Biometric information means your retina, your fingerprint and all. Now edge security in edge level, when you are in the edge level, you need to do this kinds of data collections in a decentralized edge architecture, which demands a privacy preserving authentication mechanism. Why it is required to privacy preserving authentication? Because whatever information I am putting in my device, and that data, if it is goes back to the cloud, and my cloud is also storing my data means my biometric information, my fingerprint information, my retina scan information into the cloud, that creates a biometric vulnerabilities. What is the biometric vulnerabilities means? Biometric vulnerabilities means the data that was already stored in the cloud, that can, if that get breached by someone else, I'll be in a big trouble. If my fingerprint is available with someone else, they can do anything with my data. So I can't allow my fingerprint to be get stored in a remote cloud. That's the major challenge in biometric vulnerabilities, right? So there we introduce the cancelable biometrics. Cancelable biometrics is basically offer a critical solution which don't allow the data, my biometric data, my fingerprint data, my face recognition data, my keystroke timing data, my retina scan information to be sent to the central server. Instead of that, it will do the local processing and it will send some processed data through the central server via which you cannot retrieve my original biometric information. That is what cancelable biometric algorithm will do, right? Now we proposed a OSCBA scheme overview. This OSCBA scheme, the architecture and phases are the client side enrollment. So where the client is supposed to be enrolled via a fingerprint, and using that fingerprint, he is going to with a fingerprint that was captured in the client end, that means in the age level, but that is not going to be sent directly to the server. Instead of that, the age server will do the pre-verifications. The age server perform the initial rapid verification and securely relay the anonymized template. So that means you are not sending your original information, you are hiding the information something, and but for the authentication purpose, whatever is basically required for only for authentication, that data we are sending, not the entire informations. So this will prevent our data to be get lost in the cloud. And in the cloud server, what we'll do, we finally that template, whatever we are sending to the cloud, that will get masked using the convolution neural network, and that efficiently do the authentication. And this particular idea of doing the initial pre-verification in the age level, that reduces the communication time between the edge and the cloud, as well as the data transmission is also get reduced, and also the response time is also get reduced in the cloud server. Okay. Now, this is the performance analysis, what we have done. If you see the performance analysis, here you will see that this is our algorithm, our proposed algorithm, and our proposed algorithm compared to the other one are little bit better. Better in the term of accuracy. Accuracy means when you are calculating the authentication, we have shown that our proposed algorithm is authenticating a person a little bit better than the other one. So our accuracy level is a little bit better than the existing algorithm. We have already compared with someone else. The comparative table we have also here. Okay, so comparative, I'm coming into that in the later slide. Here, the unparalleled security strength of OSABA, where we are giving the strength, the user anonymity we have introduced, so that guarantee the user identity will be remain untraceable from the cloud side, right? So this cancelable biometric will not allow you data to be directly sent to the cloud server. So now, so that the cloud authentication, whatever information is required, only that are supposed to be get sent to the cloud. Sensitive key security. So also we are session key security. Also we have introduced the session key mechanism. That session key gives us another management advantage, which is basically protecting us for long-term attack. So attacker, since we are generating some session key, so after the session is over, attacker cannot do something with us. So that is preventing us from different other types of attacks. Attack resistance also, we have done it robustly. We have proposed man in the middle attack. We have proposed the reply attack. We are also resilient to other types of attacks like impersonation and internal insider threats. So these types of attacks we have shown in our paper that I am not discussing that how we are preventing that, because this is not the area. And also I'd like to not going to discuss anything a little bit more here, because our paper is going to be published soon in a journal. So however, when it get published, and in our conference paper also we have enlightened something. There also you can find with this name, if you can go a search, you will get download the paper. They will find that how our proposed algorithm will prevent us from these kinds of attacks. So ultimately what our proposed OSCBA will enhance the protection from different types of attacks and gives us a high level of security. So if you see the architecture wise, it has a client device, it has an edge server, and it has a cloud server. So here we have, here we have proposed, we have not proposed something up as fog, rather we have proposed a cloud device. That means the device that you are holding in your hand, and also in your premises we have proposed an edge server. That edge server, whatever I have proposed, you can also call it as a fog server also, but we in our proposed algorithm we proposed it as an edge server. So this edge server will do the local processing of our data. It is something like fog environment, which will do the initial processing of the data to before it is going to be sent to the cloud, to reduce the communication, and also it will also reduces the overhead to the overall system. So it is a comparison study. Already I have shown you that our proposed model is little bit better, 97% compared to the other existing model. And what they have used, the FIGO algorithm already have used one-shot learning, and also we have also used one-shot learning, but from FIGO we have given a better performance. And these are the SBM algorithm they have used. The SBM will not give that same data set. Here I am comparing with the same data set on which we are performing our analysis. So if you see the comparative table, in the different with the different existing algorithm, we can show you that machine learning based algorithm, our proposed algorithm is a machine learning based algorithm. Mutual authentication, all three of us providing. Cancelable biometric based authentication, only we are providing. Privacy preserving methods, all of us providing. So this are where we are getter, and where this is our line. We have shown that we are a little bit better than all existing algorithms that who are proposing the same idea in the same field, right? Now, in conclusion, what we can do, what we can say, the future directions in the biometric security is that whatever the scheme that we have presenting is a robust and privacy-centric solution for biometric authentication, specifically tailored for evolving the landscape of edge computing. So we have designed something which can easily be run in a handheld device. And not only that, because of this cancelable biometric mechanism, we don't disclose the actual information to the cloud server, so that it will not get lost in the cloud. So biometric vulnerabilities can be get reduced in our proposed secure authentication mechanism. And one-shot robustness is also, we have proposed that integrate with the one-shot learning model, ensure the high accuracy and reliable performance even with limited initial biometric data. So how one-shot algorithm is giving us the advantage, that advantage we are getting over here is because of this one-shot algorithm. However, we have not done entire research. In future also, anyone can enhance this particular research in multimodal biometric fusion right? They can also introduce some kind of quantum safe algorithm authentication mechanism to enhance the biometric in the quantum chip based algorithm also, and also optimizing the computation overhead. That is, even if in our case it is a little bit high, if you have not yet shown the diagram or the mathematics behind our computational analysis, where we are not that good compared to that of where we can also enhance the model. So people can do a lot of research at there till where we can improve. So with that, thank you. If you have any question, please ask.
Participant, if you have any question, you can ask directly, or you can put your question in the chat box.
You can simply unmute yourself and can share, or let me show you that where you will get me. So let me again share my screen. Where is the screen? Okay, this is the screen. Sorry. Sorry, I reached the last slide, so that's why it was get. So as I already told you that anyone can mail me in my email address. This is my email address. You can visit me in my web servers, where also you can get my idea, and you can see my research in the Google Scholar also, as well as in the DBLP also. So these are the Google Scholar and DBLP link, where also I have shared in my the presentation, and that was already shared with you. So there also you can make me available. If you have any query, anything, you can ask me or in later also, right?
Participant, if you have any question, you can directly ask.
Any question from participants? Okay, thank you, sir, for delivering such an insightful and knowledgeable session today. Thank you so much, sir. The next session will be started soon. So now I would like to request Shashmita madam to take over and start the next session.
Our next session will start at 7:30.
Yes, I think 7:30 is the next session. The meeting will be on. So participant can stay at the meeting, or you can rejoin at 7:30 for the next session. Try to join it 5 minutes earlier. Right, Shoma madam?
Yes.